This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate. Please don't share personal information such as contact info during class for your own security reasons. Oh no, yeah, it's actually a rock and a color as well, Lolo. It's actually that color green. Cool. All right. So here we go. I have questions for you up on the board. One is just a participation. One is actually some brainstorming questions. So what are your plans after high school? Are you going to college? Are you getting a job? What job are you interested in? That could even be long-term after college. Where do you want to travel? That kind of thing. And then some brainstorming here. So what do you think happens when you cover part of a hose with your thumb? All right. So you've probably done this before to one of your siblings. Tell me what happens. Does water slow down, stay the same, or speed up? Is getting stepped on by a high heel or a sneaker more painful? Go ahead and tell me, circle which one you think is more painful to get stepped on by. And is it easier to float in water when your lungs are full of air or when they're empty of air? And again, circle which one you think. This is just brainstorm, so just best guess. What do you guys think? All right, and then get your plans up there as well. Looking good. Hi, Alexis, how are you? I'm going to go ahead and check these out. Awesome. I see Lolo on the board. Joan, Z, Candace, thank you for your participation. Get lots of answers up there. Let's see. Let's get answers from my people whose names start with A's. Thank you. I see Drea on the board. Let's get Alan and Alexis, Andrew, Antonio, Ayandela. Let's see here. Get your answers up there. Let's hear from Benjamin and Kayla and Christian. And let's see here. Who else are we missing? Let's hear from Connor and Daniel. Good. So again, plans after high school. This could be long term. What kind of job do you want? This could be what college do you want to go to? I see Connor on the board. Thank you. Waiting on Diego. Let's get your answers up there. And Fro, good to see you. Go ahead, get your answers up on the board. I see Kaylee on the board. Thank you. Let's see Jacob and Jackie as well. Would love to hear from you. Jasmine, Joshua, Anthony. Looking good. All right, got Lexi up there. Want to hear from Nani and Kirsten, Marlene. Let's see here. Who else are we missing? MJ, would love to hear from you. Awesome. I see Jacob A on the board. Michael and Raymond and Ray. Rihanna and Z. Oh, I already got Z on the board. Good. All right. Awesome. Thank you, Anthony. I see your answers up there. Oh yeah, multiple desires to be, multiple people want to be singers. Cool. Hi, Holly. Good to see you. All right, let's go ahead and start going over these answers. So let's see here. Lolo, you said modeling or hair or makeup trade school. Oh, and makeup trade school. Very cool. That would definitely be a hard thing for me to have to be so focused on that. I feel like I would just be like, I want to eat donuts all the time though. Jonesy said you want to become a cop or I think this is mechanic. Is that what you said here? It's a bit of a typo. If that's, I'm gonna retype that. Is that what you meant, mechanic? Let me know. All right. You want to do construction? Let's see here. Who said this one? Construction was Diego. Very cool. I have one of my husband and I, our best friends, does construction, and he makes bank, man. Like once you get through the union and you get through all of that, and you're like higher up in the trade, man, you make bank. Singing, Drea, very cool. Work. Who said that one? Yes, Jacob, just lots of work. Or do body art. Oh, that's a really cool one, Lexi. Do you want to sing people's songs on stage or sing your own songs? I think Drea Lolo's asking you that question in the chat box. Let's see here. Cosmetology school. Marlene, very cool. Work with animals. Oh, so you said work with animals or do body art. Very cool. Yes, animals are super awesome. Definitely very sad, though, because sometimes when you're working with animals, they don't make it, right? Going to become a chef. Oh, that's amazing, Candace. I love it. Not sure yet, it sounds like Connor. And let's see here. Go to college, become a therapist, Kaylee. Oh, that's an amazing goal. That's so nice. Oh, no worries, Alyssa. No, you're here. You're fine. Let me send you your attendance check for today. And then the U.S. Coast Guard. Very cool. Who said that one? Anthony. Awesome. So I love hearing all about all of your guys' goals. This is really cool. Let's go ahead and talk a little bit about the brainstorm. You can still type up here, but I'm going to start on our brainstorm here. It's very tiring. Yes, Connor. Yes, they are very strong people, I would say, depending on what kind of construction you're in. So the question is, what happens when you cover part of a hose with your thumb? You got this all right. Yes, water speeds up, right? How many of you have ever done this to your sibling or a cousin or something? You've put it over and it squirts them in the face, right? It shoots them in the face. You guys know what I'm talking about? Drea, you said you do songwriting and perform. That's amazing, Drea. Very cool. Yes, I definitely did that a lot when I was younger to my older brother, and he did that a lot to me as well. So we had a fun sibling relationship, right? Cool. All right. So we're going to talk a little bit about why that happens today. We're actually going to talk about all of these today. Now, is getting stepped on by a high heel or sneaker more painful? Definitely a high heel. Has this ever happened to any of you? Have you ever accidentally stepped on yourself with a high heel? Yeah, it's not fun. It definitely involves tripping and pain. Yes. All right. So yes, high heels are not fun. Let's see here. And then, yeah, it's awful. It's really awful, Connor. And then we'll talk about why that is true. And then, is it easier to float in water with your lungs full or empty? It's actually easier with your lungs full. So if you're ever panicking in water, lie on your back, fill up your lungs with air, and that will allow you to float. And then you can calm down and not be as freaked out by whatever's happening in the water, okay? Unless it's a shark, then just swim away. Just swim away, all right? But again, we'll talk about why this is today, right? Because air is actually a really light kind of gas, and so it's allowing you to float in that water, and we'll talk a little bit about why that happens. All right, so let's go ahead and make sure you have your attendance check open. I need green checks. I have 8 green checks so far. So green checks, once you have your attendance ticket open, and then the start of class word is underneath the link in the chat box. Yes, punch the sharks in their noses. Punch the sharks in their noses. I've heard that too. Is that a real thing? Or are people just messing with me? But I've heard that as well. I think so, yeah. Yeah, if you're panicking, you're using all your breath. Yeah, that's why it's important to remember, right? Lie on your back, deep breaths. Slow your breathing down. Cool. All right, waiting on green checks from Alan, Alexis W., Andrew, Ayandela, Benjamin, Cam. Good. All right. Guys, leg bit off, punched a shark in the nose, and managed to get away. Yeah, I mean, maybe their noses are just really sensitive. I wouldn't like to be punched in the nose, so. All right, here's our schedule. Today we're talking about our newest unit, which is pressure and buoyancy. So remember, we combined 2 days together because of last week we missed a day. So today is actually the 4AB notes. So it's actually 2 topics together. This is a short unit, so we do have Thursday. We have a exam, so it's coming up soon, but same thing as last time. As long as you answer every question on the exam, you automatically get a 50%, so you just need to try every single question to the best of your ability, and we do the entire exam in class together, okay? And then Friday, we have optional support session, as well as you'll have a recording so that you could do your 5A notes. All right, thumbs up, everyone, if this makes sense. Taking a look at our schedule here. It's true, I guess you could get your hand chopped off before punching the shark. Maybe you can kick the shark too. All right, so if you started class on time, this is what your grade breakdown currently looks like. So the 3D lab, those will be graded before our exam on Thursday. So I'll also be entering zeros on Thursday. So if you haven't done the 3D lab, you're going to see your grade go down by 20%. Thumbs up, everyone, if you understand. Thumbs up if you understand. Connor, maybe that person just shouldn't be in the water then. I don't know. When there's sharks around. All right, so again, if you haven't done any of these assignments, you're not going to pass my class. I have to tell you this over and over again. The lab reports and exams together make up 60% of your grade. So without the 60%, what's the highest grade you could possibly get in my course? Without the 60%, what's the highest grade you could possibly get? Yes, you could only get a 40%, which is definitely not passing. So that's why we really want to prioritize the big assignments. Doing the notes is nice, doing attendance is nice, doing Star 360 is nice, but none of that's going to get you to pass the class unless you also do labs and exams. Okay, for students who started later, you started 2 weeks into the quarter on September 9th. Keep in mind that this is your first lab report, so this first lab is currently worth 60% of your grade. Altogether, it's a huge grade, so you want to make sure you get it done and get it done correctly. Remember, I do the entire exam in front of you in the video. You just need to get the data while watching me do the lab. All right. So you want to have the audio on because I explain that in the video and I explain what I'm doing for every step, but you want to make sure you're listening to the video as well as watching it. All right. Did anyone already do the lab, finish it? How was it? Not too bad? Easy, Marlene. Okay, good. That's what I want to hear. Yeah, so you watch it, I do the lab, you just get all the data and scenarios from it. Connor. Okay, well, let me know if you guys need help on that. So we are starting our newest unit, which is all about fluid forces. All right, so we're going to talk about fluids. We're going to talk about pressure. Okay, yeah, Lolo, if you want help on that, let me know, and we can set up a time to do that, or we can do it on Friday morning. Okay? And then we're also going to be talking about pressure, shape, density through a fluid and Pascal's and Bernoulli's principles. All right, so today we should be able to define pressure, density, and buoyancy and talk about the effects of temperature, volume, and depth on pressure. So we'll take a look. Here's our agenda for today, but we're going to move quickly because there is a lot. All right, let me go ahead and send you guys your notes. Give me a green check once you have your notes open or you're ready to take pictures. Green checks, green checks. I have 6 of them so far. All right, Lolo, Andrea, as we're getting started, let's go ahead and pause on that conversation and we can finish up after class. Thank you. All right, got 12 green checks. Love it. All right, keep on getting those open, but we're going to go ahead and get started. So pressure changes with temperature, volume, and depth. Let's go ahead and do a quick brainstorm. How does a hot air balloon work? Let's see here. What do you see at the bottom of the hot air balloon? What's important about what's at the bottom of a hot air balloon? Tell me in the chat box. All of your thoughts about this hot air balloon. What do you notice in this diagram at the bottom of the hot air balloon? Yes, you should see some propane tanks. And what do you think propane tanks are used for? Tell me in the chat box, everyone. Make sure you're participating. Make sure everyone's typing. They're used for fire, right? So fire for heating. Specifically, what are they heating up? Tell me in the chat box. What are they heating up? Yes, exactly, Jacob. Yep, we're getting some heat. But what is being heated up in this hot air balloon? Not exactly. We probably don't want to be heating up the actual basket. Oh, you mean this part, right? So no, it's not exactly the actual balloon part that's being heated up. It's actually the air. Yes. So the gas, Wes, the air, Connor. Yes, we're actually heating up the air, which is a type of gas. Absolutely. All right. So we're heating up the air. Love it. Now, what do you think happens as we heat up air? Think about this, this phrase that you've probably heard. Hot air will do what? Hot air blank. Tell me in the chat box. Hot air does what? Yes, Lexi, hot air rises. It will rise. Hot air rises. Exactly. So this is why, for example, if you live in an apartment complex, the 3rd floor is a lot hotter than the 1st floor. Or, for example, in the summertime, if you don't have AC, sometimes, like when I was a kid, I would go sleep in the basement because the basement is much colder. So cold air is at the bottom, hot air goes to the top. So if hot air rises and it's trapped inside of this balloon, what do you think the balloon is then going to do? The basement is scary? No, the basement was great. It had a TV down there. It was awesome. Yes, it will also begin to rise, right? So as we have hot air inside of our balloon going up, then that is going to actually make our balloon also move upwards. And so our hot air balloon moves upwards. No, yep, that's scary, Connor. All right, what about at the top of our balloon? So at the top of our balloon, we have a parachute valve. So what do you think might happen if I were to open up the parachute valve? Right, so we've talked about the bottom of the balloon. What about the top of the balloon? What happens if I were to let air out of this valve? Yeah, so at the top of the balloon, if we start losing hot air, then we're going to start going back downwards, right? So we would descend, go downwards. Absolutely. And so this is great because this actually gives us control over if we're going up or down, right? If we want to go up higher, we add more heat. If we want to go down, we let out air. And then there are also directional controls, right? But for the most part, this allows us to figure out if we're going up or down, which gives us control of the balloon because it would be really scary to be in one of these and not have control. Go ahead, give me a smiley face if this makes sense. All of these concepts you just thought about are actually what we're going to learn today in class, talking about, Kara, stop. Sorry, can you hear me? Talking about density and buoyancy as well as pressure. Okay, cool. Okay, so let's talk about this. So when molecules collide in a fluid, this could be air or this could be water, they create and change pressure. Okay, so pressure is caused by the weight and collisions of molecules against the container surface. So the main idea here is more collisions, more pressure. Okay, so more money, more problems, more collisions, more pressure. Smiley faces if you understand. The more collisions there are, the more pressure a gas has. Okay, so what this means is that as molecules collide against their container, this increases more and more. This increases their pressure, and this increased pressure can actually exert a ton of force. So this brings us back to our brain stretch when we talked about the hose. So what's happening here is with the hose, you're actually covering the surface of the container. And with that, you're causing those molecules to collide more and more and more. And so they suddenly have a ton of force, and so they shoot out, right? And then you can shoot your brother, in my example, in the face with this really, really powerful stream of water, right? Whereas when you don't have your thumb over it, right, they have really low pressure, and so they don't shoot out as much. All right, go ahead, give me a thumbs up if this diagram makes sense, if this idea of collisions makes sense. Awesome. All right, this is number 1 in your notes. So take 30 seconds, fill in the blank with the word collisions. Give me a green check when that is saved or when you have taken a picture. Go. All right, waiting on green checks from Adrian, Alan, Alexis, W, Andrew, Benjamin, Cam, Candace, Kayla. Green checks, please. Dajane, Daniel, Erwin, Isaiah, Jasmine, Jose, Josh, Kayla, MJ, Michael, Ray, Tatiana.
I couldn't find an answer, but I'll notify you if I find one.
Alexa off. All right, the hose at my house has one of those nozzles. Your little brother uses the jet setting on you when you walk away. Yes. I did that to my husband the other day while I was washing the car. Awesome. All right. So there are some different ways that we can actually affect pressure. We looked at one of them, right, which was covering the nozzle of the hose, right? But there are other ways that we can affect pressure. We can change the weight of the fluid or the amount of fluid. We can heat the fluid up or cool it down, or we can increase or decrease the volume of the container that the fluid's in. So for example, how many of you have ever had to fill up a tire on a bike or on a car? Tell me in the chat box. How many have ever had to fill up a tire in a bike or a car? Lolo, yes. Yeah, so I will ride my bike pretty frequently. Exactly. So I've filled up my bike tires before. And what is going into those bike tires? Tell me in the chat box. You pop your tires a lot? Yeah, do you have an emergency like bike repair kit? My husband always brings one with him because he actually bikes to his work every day. Yeah, exactly. So you are filling those tires up with air. So air is not just empty space. Air is actually made up of molecules, physical things. It's just they're so small that we can't see them. They're so small and spread out, we can't see the air. But it is actually a physical substance. All right, thumbs up if that makes sense. It's inflated because there was a nail in it. Oh no, Connor. I'm sorry. You blew up your tire. Oh my gosh, that's crazy. You must have added too much. So yeah, so here's what's happening. The more molecules you add, the more pressure there is because more molecules actually result in more collisions. So let's go ahead and brainstorm and think about that. So here we go. We've got a gymnasium. All right, so we have a gymnasium here, gymnasium 1. And over here we have a gymnasium 2, gymnasium number 2. Okay, now in the first gymnasium, let's say that I go ahead and I put in here 5 people. All right, so let me go ahead. I'm going to grab my colors here. So we put in here 5 people. 1, 2, 3, 4, 5. Now, in that gymnasium with those 5 people, what do you think is going to happen? Are they going to run into each other a lot? It's a big gymnasium. Are we going to have a lot of collisions or very few collisions? What do you think? A lot of collisions or very few? Yes, exactly. So we have few people or molecules, and therefore we have few collisions. And so what do you think is going to happen with my pressure? High or low pressure? High or low pressure. What does this mean? If there are few collisions, then yes, collisions and pressure are the same thing. So few collisions means very little pressure. So low pressure. Exactly. Now, on the other hand, what happens if I go over here and I start adding hundreds and hundreds and hundreds of people? So let's say over here, I try to add 500 people into this gymnasium. What do you think is going to happen to the collisions? Tell me in the chat box. What do you think is going to start happening to these collisions? We're going to have more collisions, less collisions, same collisions. What do you think? Boom! Yes. Yes, this is exactly what happened with someone's tire, right? Who said that? Anthony, yes, with your tire. So here we end up with a lot of people. So a lot of people or molecules is actually going to result in many collisions. And with many collisions, what happens to our pressure? What happens to our pressure? RIP, right? Yes, we end up with what kind of pressure? See, Lolo's got an answer for me. High, low, same pressure. Yes, exactly. We end up with high pressure. All right, so this is a direct relationship. More molecules, more pressure. Smiley faces if that makes sense. This is a direct relationship because they do the same thing. More molecules, more pressure because there are more collisions from the collisions. Awesome. All right, let's go ahead and try out the next one. So the next one has to do with temperature. So the important thing to understand is that temperature is energy. The hotter something is, the more energy it has. So what's going to happen is hot molecules have more energy and therefore they collide more, creating more pressure. So let's go ahead and try this one out. All right, so here we go. Here's my gymnasium again. All right, and this time, let's just go ahead and put like 10 people in here. All right, so here we go. I've got my 10 people. Now these 10 people, let's go and imagine that they are just walking around. So these are just arrows. They're just kind of walking around. Tell me what's going to happen if they're walking around with very little energy. All right, so they have very little energy. They're just kind of walking around. What do you think happens to our collisions? So little energy, walking around. What kind of collisions do we have? More collisions, less collisions. Tell me in the chat box. Yeah, we're definitely going to end up with less collisions, right? People that are just walking around very slowly aren't going to run into each other. So we have less collisions and therefore low pressure, right? Low pressure. Now, on the other hand, let's go ahead and give them a bunch of caffeine or heat, for example. And now they're all sprinting around as fast as they possibly can. If they're sprinting around as fast as they can in this gymnasium, what do you think is now going to happen with their collisions? What do you think is now going to happen with their collisions? Yes, we're going to get a ton more collisions, right? So if we get them a lot of energy, then they're sprinting around. And you're definitely going to end up with more collisions. And the more collisions you end up with, what happens to your pressure? Yes, Alyssa, exactly. You end up with high pressure. Okay, so this example on the left with little energy is when we have low temperature. Low temperature. And this one on the right is when we have high temperature, because remember, temperature and energy are the same thing here. So low temperature means low pressure. High temperature means high pressure. What kind of relationship is that? The same direct or the opposite inverse? Low temperature, low pressure. High temperature, high pressure. Is that a direct or inverse relationship? So if low goes with low and high goes with high, are those opposites? If low goes with low, are those two things opposites of each other? Or high goes with high? No, so this is actually a direct relationship. Direct relationship, right? Where if one goes up, the other one goes up. If one goes down, the other one also goes down. Smiley faces if that makes sense. Smiley faces if that makes sense. This is also a direct relationship. Cool, all right, next one. So here we go. This one's a little bit different because we're going to see that this one is actually an inverse relationship. So this one has to do with volume. So volume is space. And as you increase volume, you're actually giving molecules more and more space. And as they have more and more space, they're actually going to collide with each other less because they actually have more room to move around and kind of hang out in. All right, so let's go ahead and take a look at this one. So here we go. Here's our gymnasium again. All right, and let's say that I have a bunch of people in this gymnasium. All right, they have a lot of space to move around. So what do you think is going to happen to those collisions? They have a lot of space to move around. More collisions, less collisions. So big volume means lots of space. What happens to collisions? Yeah, less collisions, right? Because they've got a lot of space to move around in. And less collisions means what for our pressure? High or low? Yep, low pressure. Absolutely. Now, let's take all these people and stuff them into the locker room. All right? So now I'm stuffing all of these people, the same number of molecules, but putting them all into this locker room. And what do you think is going to happen to their collisions as I do this? What do you think is going to start happening to their collisions as I stuff them into this locker room? It's going to be a stinky locker room, guys. What happens to collisions? Yeah, they look like little ants. They do. Yeah, we're going to end up with lots of collisions, right? So if we have a small volume, which means very little space, then these molecules or these people are going to have more collisions and definitely higher pressure, which you guys have already said, high pressure. So again, if we start out with a big volume but end up with a small pressure, or if we have a small volume but end up with a big pressure, are those direct relationships where they do the same thing or inverse relationships where they do the opposite? What kind of relationship is this? Big volume makes small pressure. Is that the same relationship or the opposite relationship? Yeah, this is the opposite. So this is actually what we call an inverse relationship, because as one goes up, the other goes down, or vice versa, as one goes down, the other goes up. All right, thumbs up if this makes sense, everyone. Thumbs up if this makes sense. All right, so volume is kind of the unique one because volume is the only one that's inverse. Cool. All right, here we go. I want you to go ahead and match these up. So tell me what happens when I do all of these things. More molecules, does that give us less collisions, therefore less pressure? Or more collisions, more pressure? What about with less molecules, higher temperature, lower temperature, larger volume, smaller volume? Go ahead and match all of those up. Go, go, go quickly. All right, going to pause your tools here, shrink these down, and start going over these answers. I do see a couple errors, so that's okay. We make mistakes, but that helps us to learn. That's why mistakes are important. Cool. All right, let's go ahead and talk about this. So more molecules. Yes, we know this one really well, right? The more molecules there are, the more collisions there will be, just like more people in a gymnasium will run into each other more, and therefore more pressure. Less molecules, on the other hand, is the opposite, right? So they're going to have decreased collisions, decreased pressure, because less people means they just won't run into each other as much. Perfect. All right. Now, higher temperature means they have more energy. They're sprinting around, and as those molecules are sprinting around, they collide more, increasing pressure. Low temperatures, cold molecules don't move as fast, and so they have less collisions and less pressure. Now, here's the tricky one, volume. All right. So I know volume's the one that most people get tricked up on, so let's go ahead and think about this. Again, larger volume means more space. If they have more space, are they going to run into each other more or less? Larger volume actually means you have more space to move around. So are they going to run into each other more or less? Yes, they're actually going to run into each other less. So this is actually the opposite, right? So this one actually results in less collisions and less pressure, whereas a smaller volume, stuffing them into that locker room, is going to result in more collisions and more pressure. All right, thumbs up, everyone, if this makes sense, right? Volume is always the tricky one, so you always want to kind of imagine the gymnasium versus the locker room. Awesome. This is number 2. I'm going to go ahead and give you 45 seconds to answer this or take a picture. Go, go, go. Green checks. Waiting on green checks, please. Adrian, Andrew, Benjamin, Kayla, Christian, Crispy. Waiting on David C., Erwin, Holly, Fro, Isaiah, Josh, Kayla, Kirsten, Lolo, MJ, Michael, Jones, Ray, Racy, Tatiana, Ty. Green checks. All right, let's keep on moving here. All right, so next thing that we're going to talk about is calculating pressure and why a high heel hurts more than a shoe. Okay, so the equation for pressure is force divided by area. And another way to say this is force per unit area. So pressure and force are very, very related. Okay, all this means is that it's the force of something based on the area that it takes up. So take, for example, a sneaker versus a high heel. Let's say the same person is wearing them and they have a weight of 100 newtons, which 100 newtons is your force, right? This is also called the force due to gravity. Right, so force due to gravity. All right. However, a sneaker has a much higher area. So a sneaker here, for example, is going to have an area of 0.1 meters squared. I know, right? Hopefully they're not walking outside like this. It looked like they were limping, right? Versus a high heel has a much smaller area of 0.01 meters squared. So let's go ahead and plug this in. So what is the force that I should plug in for my sneaker? Again, think about what the weight or force due to gravity of that person is. Tell me in the chat box, what number do I plug in for force? Awesome, I got an answer from Wes. Again, make sure you're participating, reinforcing your own learning. Take a look up here. What is the weight of the person, the force of the person? Yes, exactly. Yes, it's going to be 100 newtons. 100 newtons. Perfect. Now, what is the area of the sneaker? Okay, so again, the sneaker is like this flat one. So tell me, what's the area of the big flat one? Tell me in the chat box. Yes, this one's the bigger one. So it's just 0.1 meters squared. Awesome, 0.1 meters squared. So now what I need you to do is to plug that into a phone calculator or computer calculator. What is 100 divided by 0.1? What is 100 divided by 0.1? There we go. Answers coming in. Thank you, Ivy. Thank you, Alan. Yes, this is actually going to be 1,000, and the units here for pressure are going to be pascals. So 1,000 pascals of pressure. Okay, so again, remember this one had the big area, and we're going to see what happens to its pressure in a moment. Now, high heel, let's compare it to a high heel. So again, what is the force of the person? The force due to gravity or the weight of the person? Should be the same. So what am I putting here in this first blank? Yep, again, 100 newtons. Awesome. But this time I'm dividing by a much smaller area. So what is the small area of the pointy object? The pointy object. What's the small area? Yes, exactly. It's going to be 0.01 meters squared. Plug that in. Tell me what are you getting for this one? Now what is the pressure of this high heel that has a small pointy area? Awesome. Lolo's got an answer for me. Who else has an answer? Plug it in. I'm just waiting on more participation, guys, before I keep on moving. All right, I got an answer from Connor. Who else? Who else has calculated this? 100 divided by 0.01. 100 divided by 0.01. Make sure you're paying attention, working with us. I see Wes typing. I see Daniel typing. Yes, yes. So 100 divided by 0.01 is actually 10,000 pascals. 10,000 pascals. Thank you, Drea. All right, so let's think about this. With our sneaker, it had a big, big area, but what is its pressure compared to the high heel? Is it small or big? Is the pressure small or big compared to the high heel? Yes, 1,000 pascals is definitely much, much smaller. So it has a small pressure, okay, which is why it doesn't hurt very much to be stepped on by a sneaker. On the other hand, all right, let's think about the high heel has a small pointy area, all right, and this small pointy area, all the force is going there. So if all the force is being condensed into that small point, what do you think happens to the pressure? Take a look at our results. What happened to the pressure? It increased exactly, and we end up with a big pressure. Perfect. All right. So again, this is an inverse relationship. The bigger the area, the smaller the pressure, versus the smaller the area, the bigger the pressure. All right. Yep. They're going to have a broken foot. Exactly. This is number 3. Give me a green check when you have this saved. Fill in the blank with the word per. You have 20 seconds. It's a short word. Go. All right. Moving on in about 5 seconds. Only have 16 green checks. There are 48 of you. Need some more green checks. Awesome. There we go. All right, here we go. Moving on. All right, we're going to go ahead and actually skip this one here. All right, so the next thing that we're going to talk about is buoyancy. All right, so buoyancy is an object's tendency to float or sink. And buoyancy depends on 2 things: how dense an object is, which is how heavy an object is for its amount of space, versus the density of the fluid. Again, how heavy that fluid is for the amount of space it takes up. Okay? Now here's the key thing. If the density of an object is less than the density of a fluid, the object will float. Okay? So think about a beach ball that's filled with air. Air is much less dense than water. So since that beach ball is mostly air, the beach ball will float. Smiley faces if that makes sense. Smiley face if that makes sense. Air is lighter than the same amount of water. So air is lighter, and so it floats. Awesome. This is number 4. Go ahead, fill in the blank with the word buoyancy, and give me a green check when you have it saved. You have 30 seconds. Go. All right, waiting on green checks from Adrian, Allen, Alexis W. Let's see here. Antonia and Ayandela, Benjamin, Chris, Daniel, Erwin, Fro, Isaiah, Jackie, Jasmine, Jose, Josh, Kayla, Nani, Kirsten, MJ, Michael, Sarah, Tati, Tatiana, Ty, Z, green checks for number 4. All right, so what is density? So again, I kind of described it. Density is this idea of how heavy something is for the amount of space it takes up. But specifically, density is how closely packed particles are. So the more packed they are, the more dense something is. And the way that we can calculate this is dividing the mass of an object by its volume. So mass divided by volume, or the space that it takes up. Okay, so thinking about this, a tennis ball and a baseball actually have the same volume or size or space, right? They're the same size, but a baseball feels much heavier, right? How many of you have ever experienced that? You've held a tennis ball versus a baseball. The baseball feels a lot heavier than the tennis ball. Smiley faces if you know what I'm talking about. Smiley faces if you know what I'm talking about. Thank you, Lolo. Thank you, Drea. Thank you, Marlene, Sarah. Awesome. Oh, no worries, Holly. Thank you, Ivy, Adrian. Yes. All right. And the reason a baseball feels heavier is because it has more molecules in it. All right. So the tennis ball, baseball are the same size, but the baseball has way more molecules in it, and therefore it's much more dense. So for the amount of space it takes up, it's much heavier. There's just more stuff in it. All right. This is number 5 in your notes. Go ahead. Give me a green check when you have this saved. You have 30 seconds. Fill in the blank with the word volume. I can go back to it if we need to, but we're running out of time, so I'm trying to finish up. All right, so let's think about this. If an object is less dense than water, then it's going to actually float, right? So if it's less dense, it has less weight for the amount of area it takes up than whatever fluids it is in, it will float. What do you think happens if it's more dense? Tell me in the chat box. What happens if the object is more dense than whatever it's floating in, than the water? Yeah, it's going to do the opposite. It's going to sink. Cool. And now take a look at this diagram over here at the green object. What happens if it has the same density as water? What happens if it has the same density? Yes, it will actually be suspended. All right, because it actually has the same density, so it just floats in the center of the water. Yes. All right, now here's the important thing to think about. The mass of an object actually does not matter. So what I want you to think about is a cruise ship weighs tons and tons and tons and tons of pounds. It's very, very heavy. However, a cruise ship still floats. And the reason a cruise ship still floats is because it's actually mostly filled with what? What's inside of the cruise ship? Tell me in the chat box. I know, it's crazy how it still floats. Yes, most of a cruise ship is actually just air. And so if you have a bunch of air is definitely much lighter than water, much less dense than water. So since a cruise ship is actually mostly air, this is why it floats, even though it's still a heavy object. Give me a thumbs up, everyone, if that makes sense. All right? Give me a thumbs up if it makes sense. The only thing that matters is whether or not it is more or less dense. Only thing that matters is whether it's more or less dense. Cool. All right, so go ahead and match these up for me, and then I'll go ahead and correct them, and then we just have one thing left. Sorry, I know we're going a little bit over time, so work quickly, match these up. All right, pausing, perfect. I see they're right, so I'm just going to pause it right there. Yeah, so an object sinks, it must be more dense. An object floats, it must be less dense. And if it's suspended, it must be the same density. This is number 6. You have 30 seconds. Give me a green check when you have it saved or you've taken a picture. Go, go, go. All right, let's keep on moving here. All right, so the last thing that we need to figure out is how to calculate buoyancy. So buoyancy, again, depends on the object's density and the fluid's density. And the cool thing here is that water actually has a density of 1 gram per milliliter. And since water has such a nice density of 1, we can actually estimate the density of an object floating in it very easily. Okay, so for example, water's density is 1 gram per milliliter, but ice's is only 0.97 grams per milliliter. And what this means is that you can change this number into a percentage, and that's going to tell you how much of the ice will sink. Smiley faces if you see that. So 0.97 gets turned into a percentage, and that tells you how much sinks in water. Awesome. And this means that only 3% is left over to float, which is why, again, icebergs, it's literally the tip of the iceberg. You only see 3% of an iceberg above water. All right. This is also really important to think about because ice actually does float, right? Because if ice didn't float, then in winter, ice would sink down to the bottom of our ponds and our lakes and our oceans. And the result is it would kill a lot of things. So it's actually a good thing that ice floats so that things can still live underneath it. Right? It's the same thing why ice floats in your water, in your water glass. All right. So let's go ahead and think about this. How much would a 0.75 gram per milliliter dense object be sink underwater? Tell me in the chat box. Turn this into a percentage. How much would sink? How much would sink? Turn it into a percentage. If it's in water, it converts really easily. Yeah, exactly. So 75% would sink. 75% would sink. Perfect. All right, so let's go ahead and do your last problem together. So grab your polling tools really quickly and tell me how much would a 0.55 gram per milliliter object sink below the water's surface? What percentage of it would sink? About 8 answers. Still about 50 of you, so work quickly. Good, good, good. All right, let me publish those up. All right, looks like most of us are saying letter C, and letter C is correct here. Or not letter C, but 55% is correct here. So again, all you need to do is change that into a percentage, and that automatically becomes, in water, the amount that sinks. So follow-up question, if 55% of it sinks, how much of it do you think is left floating? Tell me in the chat box. How much of it do you think would then be left floating? Yeah, the leftover would be 45%, right? So if you take 100%, get rid of 55, then the leftover amount that would float would be 45%. Smiley faces if that makes sense. So if 55% of it sinks, the leftover 45% would therefore be floating above the water. Awesome. So the answer for number 7 is 55%. Go ahead, take 20 seconds to answer that. Give me green checks. And then we're going to go ahead and wrap up, and I'll give you the attendance word. 10 seconds. All right, I can go back to that if we need to, but I want to make sure we wrap up. So we talked about pressure, density, buoyancy, and the effects of different things on pressure. Yeah, just hold on, Jacob. So let's go ahead. I'm going to stop our recording here. Grab that, say your goodbyes, and I will see you all later. All right, so last word is okapi, which is this animal right here. Thank you so much, everyone. I will see you later. And if you missed